Thank you for joining us today. My name is Ankur Kumar, and I will be the moderator for today's webinar. I am a member of our Business Transformation and Innovation team. We focus on new and innovative ideas, never losing sight of the critical thinking and analysis that comes from our global team of expert engineers and designers. Today's technical presentation is about hot motor surface temperatures in Class 1 Div 2 locations. At Fluor, safety is our #1 priority. So normally we start every webinar with a safety topic. However, because our topic today is essentially an hour-long safety and design topic unto itself, we will omit a separate safety topic. Our speakers today will be Eddie Guidry and Carlos Martinez. Eddie will lead the first half of the technical discussion. Eddie is a senior fellow in the electrical engineering department at Fluor in Sugar Land, Texas. He has been in the industry for more than 40 years, holds a master electrician license in the state of Texas for Fluor, and is a certified ICC IAEI electrical inspector. In addition to his duties as an engineer design supervisor, he serves as a global SME in the areas of international electrical codes and standards, as well as electrical installations. He served on NEC Code Panel 11, which includes motors and other related articles for the past 20 years, and is now a principal member of NEC Code Panel 14, which oversees hazardous locations for the 2023 code cycle. Joining Eddie is Carlos Martinez. Carlos will be conducting the second half of the presentation. Carlos is a registered professional electrical engineer and a director in the electrical engineering department at Fluor in the Sugar Land, Texas office. Carlos has been in the industry for more than 30 years and is a principal member of NEC Code Panel 11, which includes motors. Eddie and Carlos are not representing the NFPA or any other standards-making organizations today. The opinions and interpretations are their own and are not endorsed by the NFPA. Electrical equipment within hazardous locations present challenges, hazards, and risks that should always be designed by qualified persons knowledgeable of all the hazards involved. While this presentation is meant to be informative and accurate, always consult with the appropriate authorities having jurisdiction for final interpretations. Now, with those items clear, I'll ask Eddie to unmute his line and begin.
Dialing in this morning. In the next half hour or so, I will briefly be reviewing the basics of hazardous locations, and then Carlos is going to discuss some important considerations for totally enclosed fan-cooled motors in Class 1 Division 2 locations regarding their internal hot surface temperatures. So I'm sure most of the folks here are familiar with this, but just to review for those that have not seen it maybe in a while, fire is a very simple reaction. For a normal fire to occur, three components must be present. You've got to have fuel, and then you've got to have the right amount of oxygen mixed with that flammable gas or vapor, and then there has to be some form of ignition, and usually it's in the form of a spark or a hot surface that will ignite the gas or vapors. There's many international codes and standards for these locations, for the hazardous locations. And the purpose of all of them, though, no matter whether it's ANSI or other international standards, is to help us define and mitigate the risk of fire and explosions. Talking about the standards, there's many American and international consensus standards making organizations, some of them are listed here, that develop these codes and standards and also recommended industry practices for electrical equipment and their installations. This list here is some of the more common ones we use here in the United States, but it certainly isn't all of them. And many of these standard organizations also recognize and cross-reference each other's standards. So for the folks on the call that may not have, years and years of experience in doing this, or maybe they are in a different line of work, and what I'm showing here is to quickly show what a typical partial hazardous area classification plan may look like. You can see here this partial plan of a process unit. You can see that to the left-hand side, there's a legend. and it's indicating the area that is class 1 div 2 groups C and D, and that's talking, the C and D is referring to the material that's present or may be present. When with a T code of T3, that's a temperature code. Notice that this equipment in the highlighted area here has a radius extending 50 feet out in all directions, since it has been identified as possibly being a source of release of a combustible material. And within that hatch clouded area, all the electrical equipment, including motors, light fixtures, everything electrical, must be suitable for that hazardous location. This is another very common chart that you may see on a hazardous area classification plan or as part of the hazardous area classification engineering data that's in documentation that's provided for a project, and it's required to be kept on file by the plant owner. So let's take a look at kerosene. There's a lot of information on the chart, but our topic today is focused on the auto ignition temperature, or the AIT, as we usually refer to it. It's the temperature at which an ignition can actually occur when a flammable gas or vapor comes into contact with a hot surface without any sort of spark. Any combustible liquid can produce vapors or gas that can be combustible. And kerosene that we're looking at here on this chart is very similar to diesel, which is at room temperature probably wouldn't be much of a concern. But as it gets hotter, the potential of it creating an ignitable mixture of gas increases. So notice here that we're highlighting the kerosene liquid. It has a T code of T3, which would create a fire or explosion if it were exposed to hot surfaces of more than 200 degrees C. Now, before we go on to the next slide, I encounter this all the time. The question is asked, does that mean that if the kerosene gas or vapor in this case is exposed to a hot surface that's 200 degrees C, does that mean immediately that when it hits 200 degrees C that it's going to create ignition? And the answer is probably not, but it could. If electrical equipment includes the T code with its nameplate or other markings, then this is what it means. On this chart, notice that the T code and the corresponding allowable maximum temperature over here to the right hand side, the T1 rated equipment, of course, is allowed to have a maximum exposed surface temperature up to 450 degrees C. In other words, it can get pretty darn hot. But as the T code's numeric value increases down to T6, the allowable exposed surface temperature decreases to 85 degrees C. So in our example, we said on that area classification plan, we could have equipment with a maximum temperature or T code of T3. And we can see here on this table that for a T3 rating, the maximum exposed surface temperature is going to be 200 degrees C. Now keep that 200 degrees C temperature in mind as we go through the rest of the presentation. Generally speaking, getting into the code, all electrical equipment that will be installed in hazardous locations must be identified and marked for that location that it's going to be used in. However, this does not mean that all electrical equipment must be listed. There's a big difference between identified and marked and listing and certified, things like that. But that's another discussion for a different day. Listing is only one method in which equipment may be acceptable to and approved by an authority having jurisdiction. Electrical equipment rated for hazardous area class locations is evaluated at an ambient temperature range from negative 25 degrees C up to 40 degrees C, unless it's otherwise rated and marked. And there are some pieces of equipment like that on the market. NEC Section 501.125 is going to be the focus of our webinar today, and it conditionally allows the use of open or non-explosion proof type induction motors, such as totally enclosed fan-cooled motors. Please note, though, that with the exception of explosion-proof motors, TEFC motors will most likely not be listed for use in a classified location. But as long as they meet the required criteria that Carlos is going to address, they can and are widely used in Class 1 Division 2 locations. So let's take a look to see if there's anything from the audience yet. Encore?
Thanks, Eddie. We'll break for a couple of questions now. Please keep typing in your questions in the Q&A panel and address them to all panelists. And remember, submitter names and company affiliations will not be shown. So our first question, Eddie, on the previous slide, you said that not all electrical equipment in classified locations has to be listed. Can you clarify or explain this a little further?
Yes, figured that was going to draw somebody's attention. And there is lately during the past 4 or 5 years that I've started hearing it, there's rumors circulating through our industry that all electrical equipment must be listed. And this is simply not true. In fact, there are some types of equipment that do not have a product standard to test it and list it too. So a great example of this is the subject of our webinar this morning, actually. These motors will most likely, a TEFC motor will most likely not be listed, but it will be a recognized component possibly. But that being a recognized component is certainly not the same thing as being listed by a NERDL or a National Recognized Testing Laboratory. For example, let's take a large induction motor, a machine that's 20,000 horsepower motor. Most likely, you're not going to have any type of product standard or certification to test that motor to. So it's going to be that takes it to another level and puts the onus on the authority having jurisdiction to determine whether all the criteria has been met and that motor is safe to be installed in that location.
Thanks, Eddie. I think you touched on this next question briefly, but if the hot surface temperature gets up to the AIT, will that always cause ignition? What are some other contributing factors?
That is a very, very deep subject. In fact, it's one that myself and several of my colleagues wrote a paper on it and published at IEEE PCIC, I guess in 2016. It is available online. Let's say, for instance, you have a breeze blowing that day, or a hard wind blowing that day, or high humidity, or it's a very cold day, or possibly it's 120 degrees outside. Let's say the surface temperature has a lot of rust and little divots in it. All those things and a whole lot more contribute to the capability of that hot surface being able to ignite a gas. So what they've done is that 200 degrees C is actually, it had most of the time for most conditions that negative 25 degrees C through 40 degrees C. Most likely it will not create an ignition, and it's got some headroom built into it, some fudge factor, so to speak. But it's always best, like I said, going back to, I guess, one of the original slides, is that's why it's so important for qualified, not just person, but actually a whole team to evaluate when you're dealing with hazardous areas.
All right. Thanks, Eddie. Next question. When during a project are electrical classification drawings prepared?
So I'm going to use the example of a green field. In other words, it's open pasture and we're going to build a new plant. There's a difference between that and how we approach a brownfield where it's an existing facility. The existing facility, and we're not going to talk about that much, but it will already have obviously existing area classification drawings that you can start with and then go from there with your modifications. But for a grassroots facility, then you're talking about basically starting it as soon as process starts, looking at the mixtures and things like that. probably soon after the P&IDs are issued and the process flow diagrams are issued, then that kicks off the engineering part of for electrical to start looking and analyzing what they've got there and what kind of equipment can be used in those areas. But when, let's say, we go into the early engineering, or sometimes we call it feed, a lot of times we've already done the initial analysis, or should have already done the initial analysis during feed or the front end. And then when it rolls into detailed design, then pretty much at the end of after everybody's done and with engineering, then we issue them the plans and all the data for construction.
All right. We're going to pause for questions now. Thank you for all the responses, Eddie. I'll now hand it off to Carlos to discuss totally enclosed fan-cooled motors in Class 1 Div 2 locations. So Carlos, if you'll please unmute your line and begin.